Power. What does one mean by power? It is the rate at which work is done or the rate at which energy is transferred. If you remember, we need energy to do work. We also know that energy can neither be created nor be destroyed. It can just be transformed from one version to the other version. Therefore, power is the rate at which this work or this energy transformation takes place. So if an object is doing work W in time t, then I will have the equation for power as work upon time. How much work in how much time? Unit for power, that is watt, W-A-T-T, and industrially you would have heard of horsepower. So the engines that we have, the automobile engines that we have, they are in horsepower. Okay, tremendous amount of energy. The credit for Watt W goes to James Watt. Do you remember who he was? Rate at which work is done can vary for an object, and hence there is the concept of average power. Why vary? Because sometimes work done would be more in less time, sometimes in more time less amount of work is done during the entire course for which the power has been supplied. So that is why what we look at is average power. Average power is total energy that is used up or consumed upon total time that is provided. Did you recollect who James Watt is? Should I give you a hint? Think about steam engines. Now try and define 1 watt of power. Define 1 watt of power. Let us now see what is commercial unit of energy. Commercial means something that is used on a larger scale. Whenever we are using energy on a huge scale in industries at household level, then expressing that energy in joule, which is comparatively a smaller too small, and considering the amount of energy that we are using, it would be a difficult number to handle with. So we generally use commercial unit of energy as kilowatt hour. We denote it as K, small k, capital W and H. Where do we use this? If you go back and check all the appliances at home, you will find a kilowatt hour capacity mentioned behind that appliance. It is actually the time, the energy that appliance is going to use. It's the time for which that appliance has been working. So if I work a particular appliance for say 1 hour, then that appliance will consume maybe say 20 kilowatt hour energy. Depends from an appliance to appliance, and it is actually this amount that we are billed for. So if you go down and check your meters at home, you will find a kilo. If you look over here carefully, you will find a kilowatt hour reading very clearly mentioned. So every month you get billed for the number of units that your house is consuming based on kilowatt hour units. Okay, now let us see what it means in joules. 1 kilowatt hour is equal to 1 kilowatt multiplied by 1 hour. So this is nothing, this is like, just let's say that we have a machine that uses say 1000 joules of energy every second, and if this machine is continuously kept working for an hour, then it will consume 1 kilowatt hour energy. Okay, so it is nothing, just an expression. And how do we relate it? It is the amount of energy that machine uses for an hour. Okay, so substitute the values in, if you want to convert it into joules. 1 kilowatt is equal to 1000 watts multiplied by 1 hour, we change it to seconds, that is 3600 seconds, and the multiplication gives you a big number, 36 and 5 zeros in joules. Now remember, this is exactly why the reason that we switched to kilowatt hours. If we continuously use joules, then these numbers would go on increasing and it would be very difficult to keep a track of it. Hence it is easier to use a commercial unit. So 1 kilowatt hour is nothing but 3.6 into 10 raised to 6 joules. This energy is used in all household levels, industries, commercial establishments, as we see all around us. Okay, numerical on power. An electric tube light of 80 volts is used for 5 hours every day. How many units will that tube light consume in a week? We know power is 80 watts, which is now over here. Look over here, the another value that is given, it is in hours. So we need to convert this watts into kilowatts. So this is 0.08 kilowatts. Time, we know it is 5 hours. Energy, remember the formula, power into time taken. Plug in the values, 0.08 multiplied by 5, that is 0.4 kilowatt hour per day. The numerical asks you to find out how many units will that tube light consume in a week. So if this is for a day, for a week it would be multiplied by 7, which is 2.8 kilowatt hours or units.